So today we are going to talk about a very widely discussed topic, which is platform engineering. It is a topic that became popular after DevOps, and the biggest discussion was about how does platform engineering change the landscape and ecosystem of DevOps. So we're going to be discussing a lot of things around those topics with Doron and Dan. And I want you guys to basically introduce yourselves and give kind of a background of what is your experience and practical touch points with platform engineering specifically, and why is this topic interesting for you?
I'm Doron, CEO of Control Plane. I was at some large companies, SAP, where I met Dan, and at VMware, where I was chief architect for the cloud services platform. And I've seen teams repeat the same set of requirements in organizations, within customer organizations and within the large organizations that I was part of. And when I came across Dan, when I was at SAP, and he started using Kubernetes and Istio when they were just incubating, I saw it's very hard to match the skill of somebody who is like an expert like Dan. And so when I was at VMware, I looked back at SAP and I said, why don't we have people like Dan that can help bridge the gap between the infrastructure and the coders? And that gave me the idea of I wanted to get Dan Wilson as a service.
Hi, I'm Dan, CTO Control Plane. My experience, as Doron pointed out, I spent a lot of time at SAP Concur and helped tons of teams get a platform up and running. And we were doing it from scratch a lot of times because the whole idea of a platform engineering team was very new then. We did have one, but we were still trying to figure it out. After trying and failing many times with teams, we ended up, I think, coming up with a lot of good guardrails and having a decent process for getting teams onboarded. But like I said, it took some tries. So
yeah. So let me do a follow-up question on that, because I personally have seen a lot of teams get platform engineering wrong, because I think it's easy to get platform engineering wrong. There are a lot of things involved. There's a lot of complexity, and there were a lot of undefined, unclear rules. And it almost felt like every team that started to develop their own internal developer platform was doing it in their own unique way, because there was kind of no blueprint for doing that. So tell me about the most surprising mistakes that you have encountered with your team when you were trying to implement platform engineering, things that they were, were surprising back then, but looking back, you may feel like, okay, that actually makes sense that it didn't work out that way.
Wow, that's a great question. There's so many things that you can get wrong, and now I have to really use my brain cells and think back of, what are some of the mistakes that teams made. I think one of them was having things not in code, not codified, but this like manual deployment process after everything made it through the pipeline. We learned pretty late in the game that things had to be very clear and documented and codified up front. But what tooling do you use for that? Do you pick, something that's very specific to one cloud provider or something that's more generic? One thing that we got really wrong at SAP was we tried to put a wrapper around Terraform to make it so teams could get up and running really quickly with, the typical components that made up our stack. But the implementation, since it was obfuscated from the developer and that Terraform process was running in the background, ended up failing all the time, and the engineering team had no idea what was broken with the Terraform templates because they didn't interact with them directly. It was a mess. Definitely don't do that. You want to simplify things, but you also want your engineers to be able to interact directly with whatever tool or piece of machinery that is doing all of the deployment, so that you didn't just create a black box for them with a bunch of errors. So that was, I think, one of the things that we got wrong that impacted folks the most, that we had to switch paths.
And what was that could be a segue into the next part, because I think making mistakes is extremely important for you to understand what does not work. That helps you introduce the best practices, because you cannot introduce best practices just by following the happy path, because you have, like, if you haven't tried enough things that failed, because a lot of things work in theory, but in practice it's completely the opposite, right? So what type of best practices did you introduce in teams that you still keep using, and you basically implemented it as part of control plane, that were specifically based on the mistakes that you did during the learning phase?
I think right in line with that whole Terraform mess. I also designed a tool that would get services up and running in Kubernetes very easily, and made different mistakes when I created that system for all of the engineering teams at SAP Concur. It was simplified. It allowed them to get things up and running quickly. They were interacting directly with an API, but it wasn't flexible enough. You need to simplify for teams, but also allow them to override all the settings and configure things exactly the way they need to configure them for their app or service, because every single one is a little bit different than the last one. Yeah. Not all apps and services, unfortunately, are the same, right? They have different requirements. And if your API or interface for your engineering teams isn't flexible enough to be able to handle all of those one-offs, then you're just going to end up creating a lot of problems for your teams.
Yeah. I think that mix of creating something that is simple to use, so having the abstraction so that it's simple to use for the developer teams, but still offering them the flexibility of overriding things in the background, giving them access to the underlying stuff, not just the abstraction. I think that's the most complex thing to actually achieve. And it also kind of sparks the debate of how much should developers own. So what is the responsibility of a development team, and where does it start? Where does it end? Like, where is that line basically that people want to draw? And I mean, it is a discussion on its own, but in general, how complex and difficult do you think it's to achieve that? And what are, again, like, different from theory, what are the practical steps that you saw in your practice that helps teams achieve exactly that combination? And I want, Doron, you can offer your perspective about that as well.
Yeah. So I worked with a lot of engineering teams and was part of a lot of engineering teams. If you look at the DevOps practice and the platform engineering practice, it's there to act as middlemen between the coder and the underlying infrastructure. And the reason for that middleman is because infrastructure is large and complex and introduces enormous cognitive load that persons writing Go or Rust or Python simply don't have enough capacity, unless you're, some people have the capacity to do both. But most engineers are great at their domain, less now less and less needing to know the nuts and bolts of the code. As we get into LLM development, they need to be domain experts and know enough about the engineering, obviously, to not make mistakes. But asking an engineer to know everything about the cloud infrastructure and their domain is a bit too much in most cases. So engineers ought to be experts at what they do, and the platform engineering team job is to give them a really ergonomic substrate to reliably and deterministically deliver their applications without cognitive load, but without surprises. So they need to declare their state. I need this to scale to 1 billion users. I need this to run in this geographic region because of compliance. I need this to never go down. They need to declare their desired state, and the platform engineer's job is to ensure that thing meets the requirements that were presented. We have spent significant amount of time on achieving that and empowering platform engineering teams, giving them the engine block that they plop into their environment to achieve that exact goal. So think of what we had achieved as an enabler for those teams. And then if you want to add.
I was just going to say there's certain non-negotiables, right? These guardrails that you need your teams to follow. And if platform engineering is done right, then all of those things that are non-negotiable become really easy for the engineering teams so that they can focus on their own app, their own stack, service, their needs, and fulfill them quickly and easily. So they get the things like, the observability and whether it's, logs, metrics, tracing, right out of the box. They don't have to do anything for those things. Mutual TLS, the resiliency, the ability to deploy in all of the places they need to deploy quickly and easily, the non-disruptive rollouts, all that stuff they get for free. And that's, I think as a platform engineering team, what you really want to see is you want to see the other teams be able to be successful quickly because of the tools and services you put in place for everybody.
And also, let me just add one more thing. You don't want to be a man in the middle, really, and be a blocker to the engineer. You want to be an enabler. So if an engineer has an idea, they can develop it on a weekend without having to talk to anyone, without sacrificing reliability, availability, security, compliance. Give them an amazing developer experience. Give them super high operational simplicity, meaning day two operations. It's not enough to deliver the app. The operational simplicity is, how do I debug it? How do I scale it? How do I monitor it, etc.? And there needs to be a clear ownership model, that people have very defined ownership, who owns what. Give the developers a golden path to developing or to the day one and the day two operations. And if you've delivered those things, like Dan said, you're successful as a platform engineering organization.
Yeah, so that's a good keyword. The clearly defined responsibilities, right? Who is responsible for what, which teams are responsible for what knowledge and tasks, and what is platform engineer team responsible for. So what happens if, let's say we have an IDP, and it's not perfect, because in most cases we don't have the most perfect ideal scenario. It's good, but there are some issues that need to be continuously fixed. So what happens when developer team runs into an issue that is on the infrastructure or platform side, which is basically the infrastructure that runs the applications? So what is the responsibility of development team here, and what is the responsibility for platform team? Like, does that sometimes lead to conflict where the developer team says, you guys are responsible for this, you need to fix this for us so that our application runs properly, whereas platform engineer says, we developed the IDP, you need to debug and troubleshoot your own app why it's not running on our infrastructure that we believe that we configured properly. So how do you handle this type of situations?
That's a tricky one, right? You want to make sure the pain's in the right place. So when there is an infrastructure issue, you want to make sure you're waking up the infrastructure team. When there's an app issue, you want to make sure you're waking up the app team. It's tricky because you don't always know. When you're getting an alert, or when something's not running the way it should be, is it not running that way because of an app issue or because of an infra issue? I think, especially nowadays, you just need to make sure that all of the data to answer that question is available and easily accessible by individuals or by agents if if you're in an org where that's possible, and you can have Claude or Codex gather all the data and answer really quickly where is this problem occurring.
And by giving, and I think by giving as a platform the data, and as an app using best practices in terms of logging and metrics, you can because the information is shared by both the engineers and the platform team, they can easily triage and determine, is it an app issue? Like we have kind of perfected over, by necessity over the years, because the inclination of our customers is always to say, hey, platform, it's your problem. And we need to quickly triage, and 80% it's really the application. You guys have done something that, makes no sense. We also ensure that the application, if it's not healthy, doesn't serve traffic, and we don't replace an existing app that's running with something that's broken the running application, to the extent that it's possible. It's not always possible, right? Because it may be serving traffic, but garbage traffic. And we have no way of knowing if it's garbage or not.
There's always going to be a blurred line there, right? Unfortunately. Like, I'll give you an example.
Dan has a lot of examples of those. Yeah, he lives it every day.
Let's say you have an app and it's failing a health probe and restarting, and the natural inclination is, it must be some sort of infrastructure issue because maybe it's run out of memory and we just need to configure more memory, or it doesn't have enough CPU or whatever. It's only happening when the app's under stress or certain times, and it's all of the replicas are having an issue. But let's say that the real problem is that the end user configured their health check to actually check all the way down to the database tier.
Yeah.
We can see it all the time. It's like, I want this thing to check every single dependency that it has before it returns back that it's healthy. And then you're in the situation where one little hiccup with the database or Redis or whatever your dependencies are will suddenly look like this massive infrastructure issue because all the replicas are going offline at the same time.
And how does usually in practice this type of situation kind of progress? So you have the application team detects there's an issue, and then you need to, do some kind of investigation to find the cause. And it could be something that doesn't look like the cause, right? And that will then define like who is responsible eventually for that. But during that process, how do you navigate the communication between the teams and collaboration versus teams blaming each other basically and throwing the thing? You do the troubleshooting to find out what the issue is. Is it a cultural thing? Do you use technology and additional tools for that? How do you make sure that this process also goes smoothly and doesn't actually kind of incite conflicts between the teams?
I haven't really seen a lot of conflicts as a result of this personally. I think everybody usually wants to get to the real root cause, and as long as everybody is focused on the data, then that usually ends up pointing everybody in the right direction, even if they have this idea in their head that it's one thing and it turns out to be an entirely different thing. Usually if you provide enough data, then it can convince anybody of the right path. So.
I concur with Dan. We haven't seen real conflicts because what drew me to computers, it's the data is what is real, and we leverage things like Slack with our customers to real-time troubleshoot. And it boils down to the most important thing in, I think, human interaction, which is communication. And if you keep the lines of communication open and you have quick communication, things get resolved. I've seen with some hyperscalers, when there is an issue, you open a ticket and you wait, and that causes anxiety to grow. But if you have immediate, and so we have a culture in our company to respond quickly, even if it's not the right person for the domain that has the domain knowledge. We respond quickly to take down any anxiety level down, but try to get to the resolution as fast as we can. I think communication is key to everything, relationship, business, and especially this kind of stuff.
Yeah. So then you mentioned implementing guardrails based on probably the mistakes that you've seen, the things that people messed up, so that you know that there's a risk there for things basically being misconfigured, security issues kind of sneaking in, so you know what type of guardrails to put in place. And those guardrails back, in IDP were based mostly on human error. So now when we introduce AI to the mix, which is an additional layer, and it is kind of a combination, it's not just a tool, but a lot of people refer to it as like a junior engineer. So it's not just a tool like Terraform, but it's more like a tool with brains, right? So when you introduce AI, you have to think about different set of guardrails, just like you would think about guardrails for, junior engineers who potentially could mess up stuff. So how does that layer on top of the IDP concept that you had experience with before? So how was it like continuing of the same trend where you just, start using AI, you see where it kind of messes up, and then you introduce guardrails? Or how was that process basically, in addition to the platform engineering, already new platform engineering concept?
I think AI is really good at copying what you have in place already. So if you already have these guardrails in place, like, there needs to be tests for everything. There needs to be a security scan in the pipeline and, whatever else, then it's able to moderately well and probably getting better every day. See what you have and copy the pattern. If you're building something greenfield with AI, I imagine it's very easy to miss all of those guardrails, especially if you're doing it with someone that is really a vibe coder and they're not really experienced enough to know that they need to have these things in place. They wouldn't have any idea what they're missing, right? So
yeah,
I think that's going to be a big challenge for people to make sure that they get those practices in place early enough so that they don't end up with a big mess that they have to fix later.
And it is important to, I think, to not just let the coding agent, have its way with the enormous surface area of hyperscalers and say, go do it, because you will have unintended consequences. And what we had done, we have seen in the news, I'm sure you have seen, AI deleting people's data and so on. So we built early on into our AI skills that we publish in our MCP server, a lot of hooks to ensure safety. The product itself already gives you an ability to roll back and have audit trail and versioning and so on. But in addition to that, when you say, okay, now tear down the environment, let's say you vibe coded an app and say, run it on control plane, and it does it. When you tell it, okay, tear it down, it won't do it even if you have, if you tell AI just do loose mode, it will say, are you sure this is going to do a destructive action? Explain what it's going to do and ask you to confirm. And we're always on the lookout for things that could be destructive, and you don't always get it, obviously. And so if you just vibe code, and so guardrails are very, very important, and we take them super seriously.
Ideally, you want to use a platform that gets those non-negotiable things in place for you no matter what, even if it was vibe coded and pushed out by someone that's inexperienced. Mutual TLS, like, sorry, not negotiable. We can't have anything running plain text anywhere.
Yeah.
Monitoring, sorry, you have to be able to know and probe and see exactly what's happening with it.
Audit trail for changes.
So on and so on, right?
Right.
Like that, like a bunch of these things you can have in place just as a part of your platform, just guaranteed in place.
Also, on the topic of AI, I think AI is a great explainer of what's happening. You have finite context window. If you want to vibe code an application that does whatever, and 85% of your context window goes into set me up a cluster, set up Istio, set up Prometheus, set up Vault, set up this. How much context do you have left for the actual application? And even if you separate the sessions and you say you're only responsible for setting up the infrastructure, that infrastructure is going to be brittle. It's going to be potentially security vulnerable, and it's not going to have those non-negotiables, right? And if you say, okay, make these non-negotiables, just you have a list, an MD file, and say, have audit trail, have this, you'll run out of context window, and you'll get something that like a very bespoke Winchester house, and also cost-wise. If Bob says, okay, vibe me an infrastructure, and Lisa says, vibe me an infrastructure, you now have a load balancer, a NAT gateway, a Kubernetes brain node, Kubernetes worker nodes, and the cost sprawls out of control very quickly. And how do you have determinism? And how do you maintain the day two operations of fixing the CVEs, upgrading the nodes, upgrading the brain, upgrading Prometheus, etc.? So day one is always easy, right? Day two is where the challenge lies, and you need to have the non-negotiables codified. That's where I think that's why Dan and I got together to build this, because this was before AI, but AI is a great enabler. Think of it as, like you said, junior engineers, or for certain areas, it's an expert engineer, because it can do amazing stuff.
Yeah.
But it can also do amazing problems for you, right? So you need, I think you need that middle tier between the intelligence and the infrastructure.
Yeah. Do you have one specific example where in an existing platform, in an IDP or an existing infrastructure, you tried to implement AI agents for more efficiency, for automation, and it didn't work? It basically failed. Either the ROI, maybe time invested, was way higher than what you got out of it, or it just didn't work because that use case specifically was not a good fit. Do you have a specific example of that?
I don't, because we found if you have the underlying, and then you chime in, I'm sure you have, but because Dan has done such a great job on his side, bringing in other engineers who have created layers above, like an MCP server, I was astonished to discover that I can tell Claude, write me an app and use Redis and Postgres and something else, and it does it. And I was blown away. I saw the platform being built, but the AI, if you give it strong APIs with strong documentation, it can do amazing things. So me personally have not seen failure. On the contrary, I've seen more success than I could have ever imagined.
But there's no doubt that I've seen more success than failure. But I have seen failure too, where I think it oftentimes makes mistakes or isn't able to solve a problem at all, is when it doesn't have enough context or the ability to filter through it quickly to get to the targeted results you need. Like imagine a complex issue that involved a database and a cache and, two different apps that were communicating with each other. If the agent that you're using to try to solve this complex issue only has access to half of that, like one of the apps and one of the databases, it's probably going to make some wild guesses as to what's wrong.
Just like a human.
Yeah, and not really see the full picture. So you need to make sure that you do have the ability to get all of the information that is important for the problem or whatever it is you're trying to solve with the agent, the solution. Otherwise, you're going to end up with some unexpected results and wasted time, most likely.
And on the flip side, was there a use case that you didn't fully believe that you could either efficiently automate with AI and it was surprisingly good? So it basically exceeded your expectations.
I love troubleshooting with AI. In case it's not already obvious, it is so great for solving those production issues, especially if you can get it the access to the information it needs. And I'm just blown away every time I use it. Wow. It would have taken me days to solve this problem, but because it had access to all the metrics and all the logs and traces and whatever else, it was able to pinpoint this specific setting and this specific app that needed to change, some open source tool that I know nothing about, but it was able to pull down the code for it and figure out, here's what needed to change. I love it.
We're blown away on a daily basis. Just yesterday, last night, I was with a couple of my engineers, doing some new integration, and I pointed the LLM at a code base that I'm not familiar with and said, give me all the instances of something. It did it instantly, better than I expected. And I was able to tell it, okay, write me a function to send in the token in the right format from this side to this side. And it was everybody looked at each other. They thought I'm a genius. I'm not a genius. I'm an architect. It was able to produce something instantly that would have taken me hours to go sift through. So it's really a force multiplier. And I welcome it with open arms. And if you were a farmer in 1907, right, you were threatened by a tractor. I don't know when tractors came to be. I'm just estimating. But if you embrace it and say, wait, a tractor can, I know about farming, but now it gives me extra muscle. I embrace it. I'm not afraid of it. You can be a great farmer. Same here. If you're a developer or platform guy, girl, use the power tool. And to me, it's a power tool, and it's an amazing power tool. I'm probably stating the obvious at this point.
But you have to sandbox it too.
Yeah, right. And we've just on the cusp of rolling out an amazing sandbox technology. I don't think you've seen it, where you can spin up very quickly as many agents as you wish, and they have now superpowers of being able to consume services across clouds, tunnel through VPCs securely, and also present the tokens to BigQuery or to RDS or to Cosmos DB, such that you don't have to deal with credentials. And you get live as the agent changes the button from blue to yellow, right? In the case of something visual, you don't have to rebuild. So you can online see the change, approve the change, and then let it go into QA or go into prod, depending on what, create a pull request or whatever action you wanted to take. But these agents can start working very easily, but sandboxed such that they cannot they cannot do bad things that are unintended. So sandboxing is very important.
you don't want to have to handhold them all and approve every single thing that they can or can't have access to. You want them
Yeah.
to just only have access to what they absolutely need and let them just do their work. Right.
Yeah,
But
by the time this video is out, probably we'll have another video on YouTube demonstrating the sandbox capacity, capability. I think it's a game changer. We're very proud of it.
Mhm. So on that note, is kind of the wrap up discussion point. Where do you think platform engineering specifically, but generally the DevOps ecosystem with the AI enablement is headed towards? Like, how do you foresee the trend basically going towards, and what part of that are you personally most excited about?
I think platform engineers will leverage platforms and not build from scratch. And the analogy is operating systems, for example. It used to be before operating systems, if you needed a payroll system, engineers would write assembly language, to make the machine do payroll from the ground up. And there was no disk access and memory access that were governed by an operating system. And when software engineers embraced an operating system and databases and other things, they became 10x or 100x, right? They went up chain. I think platform engineers and DevOps engineers will, for sure, leverage platforms such as Control Plane. They will embrace platforms that give them up power. Otherwise, they fall behind, because if you try to every time build from scratch, it's like writing in assembly language. Assembly language works, but so is buying a propane generator for your TV and a diesel generator for your air condition and a gas generator for your fridge. They work, no doubt, but they're expensive, fire prone, smoke prone, air prone, and so on. I think the smart DevOps and platform engineers will realize that they need to use tooling to get them 10x or 100x, and not try to reinvent the equivalent of Linux. And I think it will just accelerate. So platforms such as ours are great enablers. And already I hear from our users, you've turned me into a 10x DevOps. You've turned me into a 10x platform engineer, because now when I need to spin up 2 regions or I need to spin up on-prem, I get it done instantly. So I personally would not want to develop software without what Dan had produced here. And when I was working with him at SAP, I had the benefit of having Dan Wilson. When I moved to VMware, I felt I had to build everything from scratch, and it was a tedious and lengthy process. So codifying as much as can be codified, so you have these non-negotiable things. That's our mission, but I believe in it. It's not just a commercial plug. Hey, use Control Plane. I hate reinventing the wheel, and hopefully others do too.
I think that platform engineering teams have a really tough road ahead, though, too, because it is so easy to vibe code or use AI to build something new right now. And there's a lot of different paths to get things up and running quickly, whether it's, working directly with the cloud APIs or using other platforms that may not be the approved path for engineering teams to use at your company. There's going to be a lot of cowboy teams that are trying to do it on their own and bypass processes and move quickly. So I think it's critically important that whatever process these teams have in place is something that teams can use to move quickly. Because if it's not, then people are going to try to sidestep it. And as a platform engineering team, like that's probably the worst thing possible for you, because now you're having to not just learn one platform or two clouds. You're going to have to learn a whole bunch of other tools and make sure that all those core principles that you're trying to make sure everybody follows are in place for each one of those. Or you're going to have to work with the team to try to migrate them back onto the approved path. And neither of those are really great options.
So what is your personal favorite part of the trend, or where this thing is going, or what are you most personally excited about?
I don't know. It's just exciting to see teams be successful, and how quickly that's accelerating right now because of technology, because of all the tooling. Like you look at like where Kubernetes is now compared to where it was, 5 years ago. There's so much more you can do with it, and it's just amazing how integrated everything is becoming with Kubernetes and all the other open source tools that are in place right now. We're in an amazing place right now from a compute perspective, and because of AI. And because of the flexibility of all these APIs and the integration points, you can build some amazing stuff so fast. So I think it's exciting to be in this stage in time right now, just because of so much possibility and how quickly things are going to continue to evolve. And
you're only constrained by the imagination.
Yeah. It used to be so hard, and now it's so easy and fun too. Like it's, I think, way more fun than it used to be. So
100%.
Yeah, as Doron said, you're only limited by your imagination. It's not easy, because there are a lot of people and a lot of engineers who still have a very limited imagination. It could be because of the technical knowledge, but in most cases, it's because a lot of engineers are too focused on the technical side and they don't see the big picture. And I think when you combine both of what is possible in terms of the actual use cases, in terms of actual business value, the end result, and then you kind of reverse engineer it back to what is possible technologically, now especially with the AI and all the tools that a lot of companies are building that abstract away the stuff that are kind of the nitty-gritty, and then you can now focus on the actual value delivery. Like that creates that new opportunity for engineers, I think.
I agree.
100%.
Awesome. So I think that was a really interesting discussion around platform engineering, but also like we see in our community, every second question is around AI. And what my usual approach is, do not focus on AI first, especially if you don't know DevOps, if you don't know cloud, if you don't know the fundamentals. Do not focus on AI, focus on the fundamentals, because you should know what to automate in the first place. You can't start at the abstraction if you don't know the layers underneath. It doesn't mean that you have to work with the layer underneath, but you need to at least understand it conceptually so that you can actually use AI to automate this stuff. So I think a lot of the insights here is going to be valuable for people who have those questions and a lot of the engineers. So thanks for sharing those practical examples and practical experiences and insights.
You're welcome. I think that's great advice too, that you have to really understand what it's doing. Otherwise, how do you know if it's doing the right thing, right?
Yeah.
So that's especially for people that are new to this industry. So that is resounding.
Yeah, keep being curious. And if you drive a car, it's not enough to know the brake and the gas. It's good if you learn a little bit about how it works. And now, access to information isn't restricted. Everybody has more access to information than kings had, in a couple of generations ago. So keep curious. See how is, Kubernetes is a fantastic piece of machinery. You should really understand what it does. Beyond deploying containerized workloads, what's the philosophy of it? It's fascinating. And get into computer science, understand the bits and the bytes. When I was at VMware, I interviewed a person, and I don't know what gave me the insight to ask, do you know what is a bit, or how many bits are in a byte, or stuff like that? They had no idea. And it's concerning, to say the least, because you need to know what's under the layers. And so my advice to people coming into the field, don't leave any rock unturned, because it's super interesting and it will make you a better engineer, better person. So keep curious, not just in engineering, but in any domain. I think let's not let our brains rot because of AI. Yeah. Let's not be in idiocracy as a society, and keep curious and keep developing, so we're not left as a relic of we don't become just a bootstrapper of AI intelligence.
Don't be lazy.
Don't be lazy, exactly.
Yeah, we can end with that phrase now. Don't be lazy, stay curious. Awesome. Thank you, guys. Thank you.
Thank you. Great to see you.
Thank you.
Bye-bye.
Bye. Take care.